We are the Team M. I am Daryl Ray Saluta.
And I am Divine Cabigting, presenting the three example set data for our multi-level feedback queue program.
Our team will discuss the three sets of data consisting of different arrival time, burst time, and quantum time for each queue level.
So the output program will must display the given completion time, turnaround time, waiting time, summation of turnaround time and waiting time, average of each, and the Gantt chart of each queue level, and the complete Gantt chart.
For the given per set data, I will discuss and explain this example set and show how the program works correctly. So for the set 1, enter number of process is 4, and for the first round robin quantum time is 3 milliseconds, and for the second round robin quantum time is 4 milliseconds. Then enter the arrival time of the process 1. So at process 1, arrival time of 0 and the burst time of 4. Enter the arrival time of process 2, which is 3, and for the burst time is 10. And enter the arrival time of process 3, which is 7, and for the burst time is 12. Then for the process 4, arrival time is 8, and for the burst time is 6. The program processing, as you can see, there is a loading bar. Then it says 100% completes. For the first dataset, all processes sorted of their arrival time to know which process must be first executed. The first queue, showing T1 was arrived at time 0 millisecond since it has the shortest arrival. T1 was ready to execute and ended at 3 milliseconds. Since P1 has a remaining 1 milliseconds burst time, it shipped to the second queue level. At time 3 milliseconds, P2 was ready to execute in first queue level and ended on 6 milliseconds. Since P2 have remaining 7 milliseconds burst time, it shipped to second queue level. At time 6 milliseconds, second queue level was ready because there are no process arrived in the first queue. P1 utilized again in second queue level and ended at 7 milliseconds. P1 completes its burst time. At time 7 milliseconds, P3 was ready to execute in first queue level and ended at 10 milliseconds. Since P3 have remaining 9 milliseconds burst time, it shipped to second queue level. At time 10 milliseconds, P4 was ready to execute in first queue and ended at 13 milliseconds. Since P4 have remaining burst time, it shipped to second queue level. All processes are completely executed in the first queue. So at 13 P2 arrived first and continued to execute its remaining burst time. P2 ended at 17 milliseconds. Since P2 have remaining 3 milliseconds burst time, it shifted to the third queue level, which is the first come first serve. At time 17 milliseconds, P3 was ready to execute in second queue level and ended at 21 milliseconds. Since P3 have remaining 5 milliseconds burst time, it shifted to third queue level. At time 21 milliseconds, P4 was ready to execute and ended at 24 milliseconds. P4 completes its burst time at time 24 milliseconds, there is no process will executed in second queue level, and all processes are completely executed in second queue level. So P2 was ready to execute in third queue level, which is the first come first serve, and ended at 27 milliseconds. P2 completes its burst time. At time 27 milliseconds, P3 was ready to execute and ended at 32 milliseconds. all processes have been utilized and completes their burst time. Lastly, the Gantt chart was successfully shown and the program accomplished its goal completely. The following program consists of the table, Gantt chart of queue level 1, 2, 3, and for the final Gantt chart of all processes. So a table, it consists process P1 with arrival time of 0 and burst time of 4. P2 with arrival time of 3 and burst time of 10. P3 have arrival time of 7 and burst time of 12. And P4 have arrival time of 8 and burst time of 6. So this program sorted based on the arrival time to know which process first executed in queue level 1. As you can see, P1 was the first process to be executed since P1 have the arrival time of 0 and it is the shortest arrival time of all process. So P1 ended at 3 time 3 because of the 3 milliseconds quantum time, and P1 have burst time of 4 milliseconds. So 4 minus 3 is equal to 1. So P1 have a remaining time of 1 milliseconds burst time. So P1 shifted in queue level 2, and at the time 3, P2 was already executed since P2 have the arrival time of 3 and ended at 6 because P2 have a burst time of 10. 10 minus 3 is equal to 7, so that P2 have a remaining 7 milliseconds burst time. P2 shift into queue level 2, and at time 6 of queue level 1, there's no process was ready to executed. So we will go to queue level 2 to proceed the execution. At time 6, P1 was ready to execute, and P1 ended at 7, and P1 completes its burst time. At time 7, the process P3 was ready to execute in queue level 1. So since queue level 1 is the highest priority, P3 was processed. At time 7, P3 was executed and ended up to 10 time 10. Since P3 have a burst time of 12, 12 minus the quantum time of 3 milliseconds, P3 have a 9 burst time, 9 milliseconds burst time remaining. And P3 will shift into queue level 2. So since at time 10, P4 was ready to execute because P4 have 8 arrival time. So P4 was ready to execute at time 10 and ended to time 13. Since P4 have a burst time of 6, so 6 minus the 3 milliseconds quantum time of level 1, then P4 have a remaining 3 milliseconds burst time. So P4 is shipped to queue level 2. Since all the process are completely done in queue level 1, we will go to queue level 2. So at queue level 2, at time 13, P2 was first executed. Since P2 have remaining 7 milliseconds burst time, and queue level 2 have 4 milliseconds quantum time, so 7 minus 4 is equal to 3, so that P2 have a remaining 3 milliseconds burst time. So P2 ended at 7 time 17, and P3 was ready to execute. Since P3 have 9 milliseconds burst time remaining, 9 minus 4, 4 milliseconds quantum time, so it ended at time 21. So P3 was P3 have a remaining time of 5 milliseconds. So it shipped to Q level 3. Then P4 was ready to execute at time 21 and ended up to time 24. Since P4 completes its burst time and there's no process that was executed in Q level 2, we will go now to the Q level 3, which is for the first come first serve. So P2 was the first process to be arrived since P2 have a remaining 3 milliseconds burst time. So at time 24, it ended to time 27. Since P2 completes its burst time, so at time 27, P3 was executed. Then P3 have a remaining 5 milliseconds burst time, so it ended to time 32. As you can see at the bottom of the program, it shows the final Gantt chart of all processes. So at time 0, P1 was ready to execute and ended to time 3. Then at time 3, P2 was ready to execute and ended to time 6. Then at time 6, P1 was ready to execute and ended at time 7. And at time 7, P3 was ready to execute and ended to time 10. And at time 10, P4 was ready to execute and ended to time 13. Then at time 13, P2 was ready to execute, then ended up to time 17. Then at time 17, P3 was executed, then it ended to time 21. Then at time 21, P4 was executed and ended time 24. And time 24, P2 was executed and ended up to time 27. Then lastly, at time 27, P3 was executed and ended to time 32. So as you can see, there is the completion time, turnaround time, and waiting time for each processes. So P1 complete the time at time 7, P2 complete the time at time 27, then P3 complete the time at time 32, then P4 complete its time at time 24. So P1 completion time 7, P2 completion time 27, P3 completion time 32, and P4 completion time 24. So turnaround time, uh, turnaround time is completion time minus the arrival time of the process. So 7 minus 0 is 7, 27 minus 3, 24, 32 minus 7, 25, 24 minus 8, 16. So the summation of turnaround time is 72. For the waiting time, turnaround time minus the burst time of the process. So 7 minus 4 is 3, 24 minus 10 is 14, 25 minus 12 is 13, then 16 minus 6 is 10. Then the summation of waiting time is 40. So to find uh to find the average turnaround time, the summation of turnaround time divided by the entered number process, which is 4. So 72 divided by 4, which is equal to the 18 milliseconds. Then for the waiting time, 40 divided by the entered process, which is 4. So the average waiting time is 10 milliseconds. So the program complete its goal and it shows the table, Q level, Gantt chart, and the final Gantt chart.
In dataset 2, entered the number of processes. We inputted 5. in the first queue, quantum time 4, second queue, quantum time 5, third queue follows, first come, first serve. So in arrival time 0, burst time 2, arrival time 3, burst time 5, arrival time 1, burst time 9, arrival time 5, burst time 4, arrival time 2, burst time 10. So the process is now complete. The second data shows all processes sorted by their arrival time to know which processes must be first executed. So as we can see, the first queue shows P1 arrives at 0 millisecond since it has the shortest arrival time. P1 was ready to execute and it ended at 2 milliseconds. Here, P1 completes its burst time. At time 2 milliseconds, P3 was ready to execute in the first queue and ended at 6 milliseconds. We can see that P3 have 5 more remaining milliseconds burst time, so it shifted to the second queue. At 6 milliseconds, P5 was ready to execute in first queue and ended at 10 milliseconds. Since P5 has 5 more remaining milliseconds, it shifted to the second queue. At 10 milliseconds, P2 was ready to execute in the first queue. We can see that P2 started at 10 milliseconds and ended at 14 milliseconds. So, at time 14 milliseconds, P4 was ready to execute in the first queue and ended at 18 milliseconds. So, P4 completes its burst time. We can see that all processes were completely executed in the first queue. At 23 milliseconds, P5 was ready to execute in the second queue level. So P5 ended at 28 milliseconds. You can see that there's one more millisecond remaining, so it shifted to the third queue, which is the first come first serve queue level. At 28 milliseconds, P2 was ready to execute in the second level and ended at 29 where it completes its burst time. So at 29 milliseconds, all processes are then executed in second queue. P5 was the last process to execute and ended at 30 milliseconds. So P5 completes its burst time. We can see that all processes has been utilized and completes their burst time. So as we can see the Gantt chart, it shows the finalized and successful program and we accomplished our goal completely. So all in all, the complete time of P1 is 2, P2 29, P3 23, P4 18, P5 and 30. So and P5 30. So in turnaround time, we have 2, 26 for P2, 22 for P3, 13 for P4 and 28 for P5 in total of 91. So in waiting time, we have P1 0, P2 21, P3 13, P4 9, P5 18 in total of 61. So in average of turnaround time and waiting time, we get turnaround time 18.20 milliseconds and for average waiting time 12.20 milliseconds.
In the dataset 3, enter the number of process, which is 7, and the first queue quantum time is 2 milliseconds, and for the second quantum time is 3 milliseconds, and for the third queue, followed by the first come first serve. So enter the arrival time of process 1, which is 0, and burst time of 5. Arrival time of 2, which is 5, and burst time of 6. For P3, arrival time of 3, and burst time of 4. And for the P4, arrival time of 2, and burst time of 1. And for P5, arrival time of 5, and burst time of 8. And for the P6 arrival time of 9 and burst time of 5, and lastly P7 arrival time of 7 and burst time of 6. The program processing, and let's wait for completion. So 100% complete. So as you can see, the program sorted. The program was sorted all the processes which determine whose process will be the first executed. So as you can see, in queue level 1, P1 was ready to executed. Since P1 have the shortest arrival time of all process, P1 was ready to execute in queue level 1. P1 start at time 0 and ended up to 2 milliseconds. Then P1 has a remaining time so that P1 shift into queue level 2. At time 2 milliseconds, there is a P4. It was ready to execute since P4 have arrival time of 2 milliseconds. So P4 was executed. And P4 ended at 3 milliseconds. Since P4 complete its burst time, we will go now to time 3 milliseconds. And at time 3 milliseconds, P5 was ready to execute because P5 has the arrival time of 2. So P5 executed and ended at time 5. Since P5 have a remaining burst time, it shift to queue level 2. So at time 5 milliseconds, P3 was ready to execute since P3 have the arrival time of 3. So P3 was ready to execute and ended to time 7 milliseconds. At time 7, since P3 also have a remaining burst time, it shift to queue level 2. Since at time 7, P2 have P2 was already executed since P2 has the arrival time of 5 milliseconds. So P2 was executed and ended to 9 milliseconds. Since P2 have a remaining burst time, so it shift to queue level 2. Then at time 9 milliseconds, P7 was ready to execute. Since P7 has the arrival time of 7 milliseconds, P7 was ready to execute and ended up to time 11 milliseconds. Since P7 have a remaining time of burst time, it shift to queue level 2. So at time 11, P6 was ready to execute because P6 has the arrival time of 9 milliseconds. So P6 has ready to execute in queue level 1 and ended to time 13 milliseconds. So all the process are completely execute in queue level 1. We will go now to queue level 2 and start the process with their remaining burst time. So at time 13, P1 was the first process to be arrived. So P1 was ready to execute and ended to 16 milliseconds. Since P1 complete its remaining burst time, at time 16 milliseconds, P5 was ready to execute and P5 have a remaining time and ended to 19 milliseconds. Since P5 have a remaining time of 3 milliseconds, so it shift to queue level 3. So at time 19, P3 was ready to execute and ended to time 21 milliseconds. Since P3 complete its burst time, so there's no need to go to queue level 3. So at time 21 milliseconds, P2 was ready to execute and ended to time 24 milliseconds. Since P2 have a remaining time of 1 milliseconds, it shift to queue level 3. And at time 24 milliseconds, P7 was ready to execute at queue level 2 and ended at time 27 milliseconds. Since P7 have a remaining burst time of 1 milliseconds, it will shift to queue level 3. So at time 27, at time 30 milliseconds, so at time 27 milliseconds, P6 was ready to execute in queue level 2. And P6 ended at time 30 milliseconds. Since P6 completes its burst time, and all the process are completely executed in queue level 2, so there's no process to be executed here in queue level 2. We will go now to queue level 3, which is the first come first serve. Since the P5 was the first process to be arrived in queue level 3, P5 complete its remaining time and ended to time 33 milliseconds. At time, so P5 was completely the remaining time. So at time 33 milliseconds, P2 was ready to execute and ended. So at time 33 milliseconds, P2 was ready to execute and P2 ended up to 34 milliseconds. So P2 completely its burst time. So at time 34 milliseconds, P7 was ready to execute and complete its burst time and ended at 2:35 milliseconds.
For the completion time, P1 16, P2 34, P3 21, P4 3, P5 33, P6 30, and P7 35. So for the turnaround time, P1 has 16, P2 29, P3 18, P4 1, P5 31, P6 21, and P7 28, in total of 144. So the waiting time of each process: 11, P2 23, P3 14, P4 0, P5 23, P6 16, P7 22, in total of 109. So we have the average of turnaround time 20.57 milliseconds, and for the average waiting time 15.57 milliseconds. Each queue level, the program displayed a successful and accurate MLFQ Gantt chart, the TAT or turnaround time, and waiting time average, as well as the completion time, turnaround time, and waiting time were all shown.
Of course, we can run the study using the C programming language, and the command prompt was used to show program output, which is where all of the dataset problems are solved.
That's all for today. Again, I am Divine Cabigting.
And I am Daryl Ray Saluta.
We are the Team M. Thank you for watching.